Welcome to an in-depth look at the essential measurements in civil engineering. Precision is the bedrock of every successful structure. In civil engineering, measurements are the foundation of planning, design, and construction. They transform abstract plans into tangible reality. Accurate measurement is crucial for structural integrity, ensuring designs are executed correctly, controlling costs, and ultimately achieving project success without costly errors. We will explore 4 key types of measurements: linear and distance, angular, elevation and leveling, and volume and quantity measurements. Let's start with linear and distance measurements, the foundation for defining the spatial parameters of a project. Tools like measuring tapes and chains are still used for basic measurements, while advanced total stations offer high precision for longer distances and complex sites. Linear measurements are vital for land surveying, defining property boundaries, and accurately laying out the elements of the construction site according to the plan. Next, we delve into angular measurements, essential for determining direction and orientation on the site. Theodolites and total stations precisely measure horizontal and vertical angles, which are critical for establishing alignment and setting out corners of structures. These measurements are used to establish precise bearings and ensure every part of the structure is correctly oriented relative to the site and adjacent structures. Elevation and leveling measurements determine height differences, crucial for gravity-based systems like drainage. Differential leveling, using a level and staff, accurately determines relative heights across a site, setting the benchmark for all vertical construction. Accurate leveling is indispensable for planning site grading, ensuring proper drainage flow, and maintaining the correct vertical alignment of structural elements. Next up, volume and quantity measurements, vital for accurate material estimation and cost management. Volume calculations determine the amount of earthwork needed, distinguishing between cut, material removed, and fill, material added, ensuring site balance. This also covers determining the precise quantities of construction materials like concrete, asphalt, and aggregates, which is essential for procurement and budget control. Our final key area is geographic and positional measurements, representing the modern standard for site location and mapping. Modern civil engineering heavily relies on GPS and Global Navigation Satellite Systems, or GNSS, for fast and highly accurate positional data across large sites. These technologies facilitate detailed mapping, allowing engineers to collect spatial data that provides a comprehensive and accurate representation of the project environment. To wrap up, precision in measurement is non-negotiable for anyone in civil engineering. The ongoing commitment to precision, combined with advancements in technology like 3D scanning and better GNSS, continues to raise the standards for accuracy in our field. Mastering these essential measurements is key to executing projects successfully, safely, and efficiently. Always measure twice, build once.